Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Akilah Peti Jamsari. So today, I will be presenting on my thesis, which is methylene blue adsorption from aqueous solution using phosphoric acid treated oil palm trunk hydrochar. So this is the outline of the presentation. So for the background of the study, the removal of dyes in wastewater by using low-cost material such as oil palm trunk or OPT. For the problem statement, the limitation of OPT as an adsorbent is because of the limited research on the efficiency of OPT as an adsorbent and low adsorption capacity. For the significance of this study, it providing more practical and efficient techniques for removing dye, and the study summary will introduce new ideas for utilization of oil palm trunk as an adsorbent in the future. So for the objectives of this thesis, to characterize PaOPT by utilizing spectroscopy analysis to determine its physical and chemical properties, to observe the modifications made by phosphoric acid to oil palm trunk adsorption properties in terms of adsorptivity, bonding, and functional groups using SEM-EDX and FTIR respectively, and to identify rate of adsorption and maximal PaOPT's adsorbent capacity for methylene blue dye through the application of kinetics and isotope equations. So next, we move to the method preparation. So first, we will start with the raw OPT. The raw OPT was dry and grind into the small particles, and the raw OPT was heated approximately at 180 degrees Celsius for 1 hour with zero point 0.1 molar phosphoric acid. And we will produce the hydrochar or PaOPT. The hydrochar we will be used in every parameter, which is pH, dosage, kinetic, isotope, adsorption, desorption, and reusability. The hydrochar will be characterized under FTIR for its functional group and also will be characterized under SEM and EDX for its element and structure characteristic. So next, we move to the characterization of OPT, PaOPT, and PaOPT plus NB. So first, we will start with the functional group of FTI under FTIR. So as you can see, at the first broad peak, it indicates OH group. And as you can see from PaOPT to PaOPT plus NB, the wavelength was slightly decreased, and it is because of the complicated process that involves between cationic methylene blue dye with hydrochar. And next, we move to the next peak, which is at 1700 that indicates C double bond O. And as you can see, it was eliminated at PaOPT plus MB because of the significant amount of cellulose and hemicellulose and lignin was eliminated during the process. And next, we move to the same image. And at first, as you can see for the first picture, that shows for OPT, raw OPT, and it shows for uneven structure because of the presence of hemicellulose and lignin. And next, we move to the next page, which is phosphoric acid was treated, phosphoric acid treated oil palm trunk. It shows like a stream-like structure after the phosphoric acid modification, and after the ambient absorption, it shows the irregular structure. And next, we move to the EDX for OPT. It shows for the first three major elements, carbon, oxygen, and silica, and for the three minor elements, potassium, magnesium, and calcium. And OPT after the modification of phosphoric acid, it shows only three elements, which is the first three major elements, carbon, oxygen, and silica, and the other element was eliminated by phosphoric acid modifications. And after the ambient absorption, it shows three major elements, carbon, oxygen, and silica, and two new element, which is nitrogen and sulfur, that shows the MB was successfully attached to the PaOPT. So we will start with the first parameter, which is pH. As you can see, the experiment was conducted from pH 2 to pH 8, and the methylene blue dye percentage removal was increased from 12% to 92%, and the maximal pH was determined at pH 8. And as you can see, the pH ZPC was lower than pH, and the number of negatively charged sites increased on the POPT surface as the electrostatic attraction between the cation MB increased. So for the next parameter, which is dosage, the removal of MB in the bulk solution increased from 78% to 94% by the increasing of PaOPT from 0.01 gram to 0.05 gram. The reason why the removal of MB increased is because of the increasing of energetic locations or surface of PaOPT increase as the dosage increase. So the MB can attach to the more have the more surface to attach at the PaOPT. So for the next parameter, which is kinetic, it was conducted by using two models, which is PFO and PSO, and it reached the equilibrium at the 40 minutes. For the first 40 minutes, it rapidly increased and it was stable at 40 minutes and reached the equilibrium. And it was well fitted with both model. As you can see at the R square, it shows the highest value at 0.99 and it indicates that the rate controlling step is physical and chemical adsorption. So for the isotherm, the hydrochar MB adsorption capacity was determined by initial concentration range from 50 ppm to 300 ppm in the models, and it does not follow any specific model and lack of suitable model, and just plotted by using QE over CE. For the next parameter, which is adsorption-desorption, it was carried out by using different concentration of a hydrochloric acid and distilled water. It was conducted by using 0.01 molar of HCl, 0.05 molar HCl, and 0.1 molar HCl and distilled water. And the highest desorption percentage was determined by 0.05 molar of HCl, and the percentage value is 26%, and the MB was easier to remove in an acid environment. So for the last parameter, which is reusability, it was conducted by using the highest concentration of desorption for the previous parameter, which is 0.05 molar of HCl, and it was repeated by three times, and it was decreased and for every cycle. And why does the efficiency decrease? It is because of the incomplete removal of the subpigments and the loss of composite during the filtration process. So for the conclusions, the experiment successfully met all the objectives, including analyzing factors influencing methylene blue absorption, characterization of OPT, PaOPT, and PaOPT-MB properties, and determining the absorption kinetics and capacity of PaOPT. And the optimal absorption was achieved at pH 8 and 0.01 gram of PaOPT following isotherms and kinetic. So for the recommendation, I suggest that industrial wastewater should be employed in the adsorption studies to assess the efficacy of adsorbents, and it is necessary to conduct a true sustainable review of adsorbent by using LCA or life cycle assessment, which covers everything from adsorbent preparation to safety evaluation in terms of managing risk, the environment, and human health. So this is the reference that I use for my thesis presentation. So that's all from me. Thank you.